Let me ask you a question. Do you know your blood type? If you're like me, the answer to that question was probably, I have no idea. But blood type is extremely important if you ever need to be given blood for a medical procedure that requires a blood transfusion. A person's blood type is the classification of the antigens on the outside surface of their red blood cells. And during an organ transplant or a medical procedure that requires a blood transfusion, it is crucial that the donor's blood type is compatible with the recipient's blood type. Otherwise, there's a risk of a fatal immune response. The antigens in blood types A and B have the same core structure as blood type O, but A and B differ by having an extra sugar molecule on the tip of the antigen. For this reason, blood type O is known as a universal donor blood type. Since it lacks the extra sugar molecules that blood types A and B have, blood type O can be donated to any patient without risk of causing an immune response. So this has really garnered some interest from a group of researchers at the University of British Columbia who have developed a process which can greatly improve patient accessibility to blood. Through the use of naturally occurring enzymes, Dr. Stephen Withers, Dr. Jay Kizekadathu, and Dr. Peter Rothfeld have established a method to remove the extra sugar molecule from the tip of the A and B antigens, effectively turning those blood types, A, AB, or B, into blood type O. Now, how do they do this? Well, as it turns out, the antigens that determine our blood type are also found on the lining of our gut wall. And there are bacteria in our gut that contain specific enzymes that are able to clip the sugar molecule from the tip of the A and B antigens as a source of food. Knowing this, the UBC researchers were able to isolate those enzymes through a series of experiments. In order for this to work, however, the enzymes need to be removed from this enzyme blood mixture that the researchers have created so that these enzymes are not given to the patient along with the donated blood. This is why the researchers are also working on an enzyme filtration device, which means that this technology will actually be classified as a medical device and not as a drug. A medical device generally has an easier pathway to regulatory approval when compared to a drug. Bypassing the need to separate red blood cells for transfusion purposes not only means that any available blood is acceptable for any needing patient, it would also rapidly expedite the process of providing medical interventions for wounded soldiers, and would also show a huge benefit in cases of disaster and in remote communities where a variety of blood types just may not be available. The usefulness of this process doesn't stop with blood either. Since vital organs also contain blood type antigens, this process can be used to convert all donated organs to type O and eliminate the need for blood type matching during transplant procedures. In fact, Dr. Withers, Dr. Kizekadathu, and Dr. Rothfeld have started their own company and are already working with people on converting hearts, kidneys, and other organs.